For countless generations, humanity has looked up at the vast expanse of the night sky, filled with curiosity about the universe's many unsolved mysteries. In the 20th century, scientists introduced the Big Bang theory, which attempted to explain the origin, evolution, and expansion of the cosmos. However, despite its widespread acceptance, this theory still struggles to answer some of the most fundamental questions about the universe. New discoveries in recent years have added even more complexity to these cosmic riddles. For example, in 2023, NASA's James Webb Space Telescope made a groundbreaking observation. It detected celestial bodies that appeared to be older than the universe itself. This revelation has left experts astounded and has sparked a debate on whether it's possible for stars to exist for a period exceeding the universe's age, according to James Webb's latest discovery. This paradox challenges our current understanding of cosmic events. Does this anomaly imply the need for a completely new model of the universe? These questions and many others will be explored in this video. If you wish to stay updated on the latest cosmic developments, don't forget to subscribe, like the video, and activate the notification bell. Around 200 light-years from Earth, in the constellation of AI, lies a star known as HD 14283. What makes this star particularly intriguing is its incredibly high velocity, moving at 4,183 km/s, which provides valuable insights into its tumultuous history. Around 1 billion years ago, during a period when our Milky Way was still forming, it collided with a dwarf galaxy, which was home to this particular star. However, the most astonishing feature of HD 14283 isn't its speed, but its age. This star is one of the oldest celestial bodies ever observed, earning the nickname Methuselah in reference to the biblical figure who, according to legend, lived for 969 years. Initially, estimates suggested that its age was a staggering 16 billion years, but newer calculations have revised that to 14.46 billion years, with a margin of error of about 800 million years. This discrepancy creates a significant puzzle when compared to the current estimate of the universe's age, around 13.8 billion years, as determined through observations of the cosmic microwave background. This raises the pressing question: what is this colossal structure? How could a star be older than the universe itself, which seems impossible based on our current understanding? This paradox has led scientists to reconsider the accuracy of our methods for dating both stars and the universe, prompting further investigations into these astronomical mysteries. To better understand this issue, it's essential to recognize the challenges involved in calculating the age of celestial bodies. Stars like our Sun maintain relatively stable temperatures and sizes over billions of years, making their age difficult to determine with precision. Astronomers analyze subtle changes in a star's brightness and color over time, then compare these observations to theoretical models that predict the life cycles of stars. One key indicator for determining the age of a star is its rotation speed. Just as a spinning wheel slows down due to friction, stars gradually lose rotational speed. By comparing the rotation rates of stars of various ages, astronomers have developed mathematical formulas that allow them to estimate a star's age using a method called gyrochronology. Methuselah, the star in question, is indeed ancient. Based on current estimates, it is the oldest known star in the universe. Rather than pondering if it could be more than 2 billion years older than its surroundings, we can approach this from a different angle. Could it be that the universe is not as young as we once thought? Understanding the vastness of 13.8 billion years is no simple task. If we were to condense the history of the universe into a cosmic calendar where the Big Bang marks the striking of the New Year's bell, Earth would only emerge towards the very end of December 31st, while human history would only span the last few seconds of the year. Astronomers calculate the universe's age by studying light from distant stars that formed hundreds of millions of years after the Big Bang, while the universe continued to expand, creating the phenomenon known as redshift. By evaluating both the observable distance, and the expansion of the universe, the current estimate for the universe's age is 13.8 billion years. However, new research from the University of Ottawa has proposed an intriguing theory suggesting that the universe might actually be much older, around 26.7 billion years. Professor Rajendra Gupta, a physicist from the University of Ottawa, has presented a hypothesis that combines Swiss astronomer Fritz Zwicky's 1929 theory with new concepts in physics. His theory suggests that protons lose energy over vast distances, in time, a concept that contradicts current data about redshift. Gupta proposes that by allowing this theory to coexist with the universe's expansion, we could reinterpret redshift as a hybrid phenomenon, not solely attributed to expansion. This reinterpretation could lead to a new estimate for the age of the universe, potentially offering solutions to long-standing cosmological questions, some of which have recently arisen in the wake of NASA's findings. Gupta's work builds upon the tired light theory and the concept of evolutionary interaction constants, originally proposed by theoretical physicist Paul Dirac, suggesting that certain cosmic interactions may have evolved over time. It's important to note that our understanding of the universe's age has evolved over the years. For instance, in the 1920s, Edwin Hubble proposed that the universe was only about 2 billion years old, but subsequent observations have dramatically increased this estimate, eventually reaching the current consensus of 13.8 billion years. Regardless of whether we consider human history as a mere 10 seconds or 5 seconds on the grand scale of cosmic time, it is clear that the universe is extraordinarily ancient. Its continual expansion forces us to reconsider previous assumptions about its age. At the same time, there are intriguing new findings regarding our own Milky Way galaxy. Recent measurements indicate that stars in the outer regions of the Milky Way move at a much slower pace than their counterparts in other galaxies. Several possible explanations for this phenomenon have emerged. One suggestion is that our galaxy may contain an unusually small amount of dark matter, an invisible substance that plays a crucial role in the gravitational forces of cosmic bodies. Another possibility is that our understanding of dark matter and its distribution throughout the universe might be fundamentally incorrect. This dilemma stems from data collected by the European Space Agency's Gaia satellite, which has mapped the positions of nearly 2 billion stars within the Milky Way. These observations have prompted astronomers to reconsider their models of stellar behavior, particularly in the galaxy's outer regions. The speed at which stars travel is an essential factor in calculating a galaxy's mass, as the gravitational forces on stars depend on the total mass of the galaxy. A recent study based on data from the Gaia satellite suggests that the mass of our galaxy, including gas, dust, stars, and dark matter, is around 200,000 billion times the mass of our Sun, 5 times lower than previous estimates. This reduction in mass could be due to the unexpected decrease in visible material in the Milky Way, possibly indicating less dark matter than once believed. However, calculating a galaxy's mass is notoriously complex, and there may be uncertainties in the data from the Gaia satellite or the analysis methods employed. As new information becomes available, we will continue to monitor these developments closely. In the coming years, advancements in technology and new space missions will likely shed more light on these pressing cosmic mysteries. The James Webb Space Telescope, with its unparalleled capabilities, is set to continue pushing the boundaries of our understanding of the universe. It's not just the age of stars or the universe itself that we are trying to understand, but also the intricate dynamics of galaxies, dark matter, and the forces that shape cosmic evolution. The expansion of the universe remains a central focus of astronomical research. But as we gather more data, we might find that our earlier assumptions were incomplete or even incorrect. One of the key questions we must ask is whether the laws of physics, as we understand them, apply consistently across all scales and times. Could there be unknown forces or phenomena influencing the way galaxies move and stars age? As our observational tools become more refined, we may discover new aspects of the cosmos that will challenge even the most well-established theories. Scientists are becoming increasingly aware that their understanding of dark matter, dark energy, and the fundamental forces may be far from complete. Each new discovery, from distant galaxies to stellar remnants, offers tantalizing clues about how the universe works. But it also opens up more questions, pushing the boundaries of our knowledge further. The boundaries of what we know. The idea that stars could predate the universe, or that the universe might be older than current models suggest, forces us to rethink our entire approach to cosmology. It could point to the need for new physics, new models, and perhaps even entirely new ways of looking at space-time itself. It also raises profound philosophical questions about the nature of existence and our place in the vast expanse of the cosmos. If these findings are confirmed, they would not only reshape our understanding of cosmology, but also profoundly alter how we view the very fabric of reality. As the debate over the true age of the universe continues, it's clear that we are at the precipice of a new era in astronomical discovery. The coming decades could provide answers to questions that have puzzled humanity for millennia. Whether it's the potential of older stars or the deeper mysteries of dark matter and dark energy, the universe still holds many secrets waiting to be unraveled. The path forward is one of exploration, hypothesis, and continuous refinement of our understanding of the cosmos. So, while the answers may not be clear yet, the excitement of discovery is only just beginning. Stay tuned for more updates on these groundbreaking studies and theories. Keep your curiosity alive, and who knows what new frontiers of knowledge we might discover next. If you want to stay up to date with the latest in astronomy and space exploration, make sure to subscribe to our channel, hit the like button, and turn on the notification bell so you don't miss any future updates. As we venture deeper into the study of the cosmos, the future holds the promise of revolutionary discoveries. The James Webb Space Telescope, with its advanced imaging capabilities, is poised to be a game-changer in unraveling the mysteries of the universe. Already, it has begun to reveal stunning new details about distant galaxies, exoplanets, and other celestial phenomena. But this is just the beginning. As Webb continues to explore the depths of space, it may uncover data that challenges our very understanding of the fundamental processes of the cosmos. One of the most exciting aspects of this ongoing research is the search for planets that might support life. With new discoveries of exoplanets in the habitable zone, the potential for finding extraterrestrial life has never been more promising. While these discoveries don't provide definitive proof of life beyond Earth, they open the door to the possibility that life may exist elsewhere in the universe. The discovery of even microbial life on another planet would have profound implications for science and philosophy, reshaping our views on biology, evolution, and our place in the universe. Moreover, as we continue to study the mysterious forces of dark matter and dark energy, our current models of physics are likely to be tested and refined. These elusive substances make up the majority of the universe's mass energy content. Yet, we still know very little about their properties or how they influence the structure of the cosmos. Some of the most significant mysteries in modern physics involve understanding the true nature of dark matter and dark energy and how they affect the expansion of the universe. If researchers can unlock these secrets, it could lead to groundbreaking insights into the fundamental nature of reality itself. In addition to these cosmic discoveries, another area of focus is the ongoing investigation into the behavior of galaxies and their movements. The discovery that stars in the outer reaches of our own Milky Way galaxy are moving more slowly than expected has prompted astronomers to reconsider their models of galactic dynamics. This observation could suggest that our galaxy, and possibly others, might not contain as much dark matter as previously thought. If dark matter is not as abundant as we once believed, it could have profound implications for our understanding of gravity and the overall structure of the universe. This is a perfect example of how new data can force us to revise our theories and assumptions, sometimes in ways that challenge even our most fundamental ideas about the cosmos. Similarly, the discovery that galaxies may evolve in ways that we have not yet fully understood highlights the need for a more nuanced approach to cosmology. Could the universe be much older than we think? Are there elements of its history that we have yet to comprehend? These are the types of questions that scientists will continue to explore in the coming years as they gather more data from both existing and upcoming space missions. As these mysteries unfold, it's clear that our current models of the universe are not the final word. There is so much more to discover, and the more we learn, the more we realize how much we don't know. This sense of wonder and the ongoing search for answers are what drive scientific exploration and discovery.